In our previous video, we have already seen the structure of neuron. Now let's check how in neuron the nerve impulses transmit. As we have said that the sense organs has receptors which helps to conduct whatever disturbance is there as electrical impulses, and how this electrical impulse is there in an axon fiber. So as we know, a neuron have axon fiber. This is a structure of axon fiber alone. And if we see the permeability of this membrane, in a normal state, it will be like its outer will be always positive and the inner side of the axoplasm, this is the axoplasm, this is the axon, this is the outer part, this is the outer part. So I am just drawing along this line so that you can easily understand it. So the outer membrane will be always positive and the inner membrane will be always negative in a resting state. So the axon is resting now and I am making a disturbance. At the stage of disturbance, somehow this electrical impulse is getting disturbed. So what happens? Some channels in this membrane open, like sodium channels. This will open and this will cause for the influx of some of the charged ions to axoplasm and causing a change in polarity, like the inside becomes positive and the outside becomes negative, and this is called as an action potential. This is what happens at resting stage, called as resting membrane potential. So as we know, when an axon is resting, its polarity is like the outer membrane is positive and the inner one is negative. But when there is some disturbance, like some impulse is coming, like some stimulus is coming, if in our eyes it is received by photoreceptors, some smell is coming, it is received by our olfactory receptors, and touch, it is by tankoreceptors in the skin. So when there is some stimulus, there is change in polarity of the membrane where the outer membrane became negative and the inner becomes positive. And there is, then when we see, the very next place will be in a resting state. It is not like the whole axon membrane goes for a different change. It's like the very next place will be same as the initial place. And this flips on charges, like from positive to negative, the electrons moves, as we know, like current moves, there is a change, there is a movement of this action potential through the entire length of this axonal membrane. And this is how in an axon or in a nerve fiber the electrode impulses gets transferred. And what happens at the end of an axon? As we know the structure of a neuron, it is having dendrites which receives impulse from the receptors, and there is the cell body and there is the axon fiber, and as we have said, through the axon fiber these impulses are getting transferred as electrical impulses all through the length, and it reaches up to this knob, and it is the end of one neuron. So there will be another neuron associated to it, or maybe a muscle to which it is supplied. So what happens at that junction? That is maybe either a neuron junction, or maybe a neuron muscle junction. That is called as a neuromuscular junction. At the end, since we know there is a difference in charge and it is transmitted up to the end of this neuron, and if we are drawing that synaptic knob in particular, it will be like this, and there will be the next neuron which I am drawing like this. So this is the next neuron or a muscle, maybe a muscle to which that neuron is supplying its impulse, and this will be having several vesicles at the end. And these vesicles contain some chemical substances called as neurotransmitters. So, as the electric impulse is passing all along the length of this axon and reaching the synaptic knob, where there are many vesicles containing chemicals called as neurotransmitters, this impulse causes these vesicles to move close to the surface of the membrane of synaptic knob, and this moves slightly and it opens up as this into this space called as synaptic space or synaptic cleft. So here the chemicals are poured since the electric impulse causes the movement of these vesicles near to the membrane, and it opens it and causes the chemical transmitters to reach the synaptic cleft. And from this cleft, with the help of some receptors in the surface of the muscle or the neuron, these chemicals enters the next neuron or muscle and causes change in polarity in this. So this is how usually a nerve impulse is conducted at the end of an axon fiber or a synaptic cleft. Sometimes this type of impulse transmission is called as chemical transmission. This type of transmission is called as chemical transmission, and sometimes the end of the axonal knob will be so close to the next knob so that there is very little synaptic cleft or space is so minimized, so that sometimes electric impulse can jump from this first one to the second one, and this is called as electrical transmission across one neuron to the next neuron. This is more fast when compared to chemical transmission, but the thing is that this usually never happens in our body system. Only in a few places where the nerves are so close to each other so that the electrical impulses can jump from one to another. Mostly in our body system, it's always like the electrical impulses are transmitted from one neuron ending to the next neuron or to the muscle through chemical transmission. So in this video of impulse transmission, we have seen how an electrical disturbance, that is an impulse, moves through an axon membrane, and how it is transmitted from the end of an axon membrane to the next neuron or to a muscle. Here, first we have seen that in an axon, always the resting membrane potential, where the outside membrane potential will be positive and the inside will be negative in a resting state. And when there is some disturbance, this disturbance causes the receptors in the membrane to open and change in polarity of the membrane caused. And this change in polarity of membrane is transmitted all along the length of this axon fiber. And when it is reaching the axonal knob or the synaptic knob, where sometimes it may be having some chemical containing vesicles which will throw its chemicals to the space between the two neuron or muscle, and these chemicals can cause the opening of channels and change in polarity of the next neuron or the muscle fiber. Or sometimes the two axonal knobs will be so close to each other, like the next neuron will be so close to the axonal knob so that the impulse could jump from this one to the next one and is called as electrical transmission.